Hello learners, welcome to Education Program Online with me, Teacher Christine Adekul, taking you in mathematics for Senior 3 and Senior 4. So learners, our topic still remains real functions and limits. The previous lesson we had just introduced what we call the inverse of a function. The inverse of a function. Inverse of a function. So the inverse of a function, we said inverse of a function. Inverse simply means to interchange, or sometimes in other books we say it is opposite. So the function here simply we know it as a relation between the two variables. So if we are asked to write the inverse of a function, then you have to look at the equation that is given to you. Is the equation, if equation is positive, then it will automatically change to a negative. We had some examples and we are proceeding to the next examples. That is example 3. We look at example 3. So example 3 say that given that function fx equals to 3x plus 2 equals to 3x plus 2, determine a inverse of fx, which is f raised to negative 1. F raised to negative 1. And then b says determine the range and a domain. Range and a domain of the function, the inverse of function x. So learners, this is our question. They said write or determine the inverse of this equation, which is 3x plus 2. And then part B, after determining the inverse, can you determine what we call the range and the domain of the inverse? So for us to get the inverse of this, then we look at the solution. So we said our solution is fx equals to 3x plus 2, of which, remember when we introduced the inverse, we said fx, since it is containing what we call the relation, the function, that means we must have the two variables present, that is x and y. So this rule, we can say it is y equals to 3x plus 2. So it is from here that we can now go ahead to find what we call the inverse of this function. Then now we say if y equals to 3 plus 2, how do I get the inverse? So for you to get the inverse, then you have to isolate to make the x a subject. And if we are to make x a subject, that means we are going to displace positive 2 from this side. And then when it crosses this side, its equal signs, it becomes a negative 2. 2 will be displaced as a constant from this side and comes to join the y side. And then now we shall have y minus 2 equals to 3x. So y minus 2 equals to 3x. Our aim is to know what is x alone. Since there are 3x, we are going to divide both sides by 3. So we shall have y minus 2 equals to 3x divide both sides by 3, so that you will have now x as equals to y minus 2 over 3. So after up to this level, this is where now you are going to rewrite this outcome or the results now in what we call the inverse. So now you come and say, therefore, f raised to negative 1 of x equals to y will be substituted by x. So where there is y, you now say it is x minus 2 over 3. So this is your answer. Rewrite the function by substituting x in y to get the inverse. So this is what once you have got it, you have got the value of x alone. It is from this stage that you are going to rewrite it, and rewriting, you substitute y with x so that you produce what we call the inverse of that function. And then that is for our example 3. So let us look at example 4, which is a bit different from this. So example 4, we say, example 4, so the part B, there is part B which says the range and the domain. So we said if we are looking at the range, you automatically look at the outcome here. When you look at this function, what do you say about this function? Is it a defined or undefined? So you find that because of this division, the function is undefined. And therefore, if it is undefined, you simply say the range is all the real numbers of x, or the real numbers of x. Range and domain are all real numbers. All real numbers. That's how we just completely comment in. So when you look at example 4, example 4 says determine the inverse of the inverse function or function h of function h equals to x square, where x is greater than 0, So learners, if we are given a question in that form, you have to identify what kind of a function is or the equation given. Remember that in our previous lesson we said there are equations which are divided into two parts, that is the linear and quadratic. So this is a quadratic equation, and they are asking us to find the inverse of this quadratic equation. So for us to find the inverse of this, we simply say let y be x square. As simple as that. Let y be x square. So if y is x square, which has replaced what? H, the h, because we said in any relation, there must be the two variables that we are targeting is the x and y. So no matter they give you a different function letter representing that function, if we are finding the inverse, then you have to replace that function by what? By y. Then now after that, that's when now you apply your rule by saying that if y equals to x square, what is x alone? What is x alone? So we simply add to root. Remember we said if it is a quadratic equation and you find that the variable is powered by 2, for you to get the root, the results or the outcome of that variable, you have to square root the what? X. So you get x root x equals to plus or minus root what? Root y. You root both sides so that this root will cancel with the power, and then you remain with the y equals to plus or minus a root of y. So to that extent, now you simply say, since I've now got the value of x, what next? You will now come to this level, rewriting the functions by substituting x in y to get the inverse. So you will now simply come and say, therefore my inverse will be f raised to negative 1 of x, or you say it is h raised to negative 1 of x equals to, it will now be a root of what? A root of x, which will be now a root of x as your answer. So if you look at these two examples, you will find that whereas inverse taken its place, it has taken its place by interchanging. You find that here it has been x and here it has been y. So when the inverse takes place, it interchange. Where y is, it takes a place of x, and then the place of x will be taken by y, which is we simply come back as the inverse of the given function. So this is our final answer. So with those examples on the inverse, I believe we have got at least something on how do I get the inverse of a linear equation and then the inverse of a quadratic equation. That is the most important thing for your level. And with that, I would leave you with some questions. As your exercise, you try to put down these questions. You will do it in your free time. Determine the inverse of the following. The inverse of the following. The inverse of the following questions. Or functions. So you shouldn't get confused when they say equations. They are the same, they are still dealing with the functions. And then they say we have function x equals to 3x plus 4. Write the inverse of it. B, we have a function x equals to x squared plus 3. And then C, we have function x over 2 plus 4 plus 4. So D fx equals to x squared. So dear learners, you try to attempt those questions following the examples that we have had. And then now from here, I want us to look at what we call the composite functions. The composite functions. Composite functions. Composite functions. So, learners, this is where we are picking again up, that is composite functions. Composite functions. When you look at all what we have been looking at from the introduction of functions, you find that we have been dealing with what we call the singular functions, dealing with only one function. But where you have now what we call the composite function, what does it mean? The composite function simply means more than one, having more functions. You are asked to coordinate the relation in more than one function. So if we are to coordinate the relation in more than one function, what are you going to do so that you see that the relationship contains in good terms? So we simply say a composite function, a composite function composite function So for those who are taking additional mathematics, they will always ask you define the composite function, because this is the topic that cross cuts both maths and additional. So they will say, what is a composite function? So you say a composite function is a function obtained by successively applying two or more functions. I will explain, then you will understand it well. The results of a composite function is obtained by applying one function to another. For instance, or for example, we can have fx equals to g, open bracket, you have x, open bracket, x, close the bracket. Or we may say it is g f x meaning that first apply h to x or f to x. In the other books we say a composite function, or we may say a composite function is a function made up of different or more functions. Take note of this. The order of a function that makes up a composite function is very important. A composite function is very important. So learners, let me explain this part so that you can understand what a composite before we go to its calculation. So in the other books we say a composite function is a function obtained by a successfully applying two or more functions. What does it mean? It means that for you to obtain the relation that is more than one, then you must be you try to apply all your techniques of bringing all the two functions of different functions, try to bring them together, and you try to see that the relation, there is a mutual relationship between or among the different functions. Looking at this, we said, for example, we can have g open the bracket h, open the bracket x. In this, these are already different functions. We have function g and function h. So what do? We make sure that for us to get the relationship between two of them, we try to bring them all together. And then sometimes in other books we say it is f g f. So it shouldn't confuse you. If you get g h, is the same as g f. So h is substituted by f. So meaning that if you are to obtain this relationship, then you have to apply the what? You have to apply h to x, meaning you have to apply this h first to x, and then or you have to apply the f to x before you bring in the outside one, which is the g. That is what it means. In other books they say a composite function is a function made up of different or more functions, as simple as that. And then the note that you need to take note up here is that if I'm dealing with a composite function, the order is very important. You have to follow the order. You have to observe the order. who comes first, who comes next. So if you continue like that, then you'll be able to see that the two different functions will maintain a good relationship. But where you you mix them, then the relation will be broken down. So let us look at the examples. So example 1, we say, given that fx equals to 2x plus 1 and gx equals to 4x full stop. Find a gf, b, we have fg, c, we have gf in 0, and then we have d, which is fg 2. So that is how these questions of a composite functions look like. They will give you a function 1 and then another function. That means there are more than one function. So for you to come up with the solution or the results, then you have to bring both of them together. Which one? You first bring the f in, the g in h, or the f in x. So for example, here they have said if function f is 2x plus 1, that is the rule for this function, and then the rule for g is 4x, and then now they're asking you find a gf. So gf, we look at the solution, we say a, that is gf of x equals to gf of x. For us to get this, we look at what is f, which is our first here. So we shall have f, function f is given as 2x plus 1, and then function g is given as 4x. Now if we are to find now the gf, that means we are going to have two. Look at this. We have the two functions contain all the variables, and the coefficient of x in f is 2. The coefficient of x in g is 4. Now here they are saying gf, which one comes first, is very important for you to take note. So it means that f is going to be out and then g will be in. So you will have f in g. That is how you'll make it x, and then now meaning that the coefficient of x of f is going to be out multiplied by the coefficient or by the rule or the function g. So which will give us the coefficient of x is 2. So we shall have 2 out into the function g, which is 4x, plus, remember that in the function f we have a constant which is 1. So that constant will not be, it will be outside there. And then now you will open your bracket. You say when I multiply 2 times 4x, I will get 8x, and then plus, because this constant is outside, plus 1. So our GF of x will give us 8x plus 1. Learners, why is our answer remaining in unknown? It is because here from the question here they have not given us the value of x. So therefore our answer must also remain in unknown. So that is for part what? Part A. And then we look at the solution for part B. So for part B says it is FG, meaning that it is G who is going to control F in that case. So part B we have FG of x. So it means we are going to have G out and F in. Meaning that you are going to interchange them. The G will be outside and then F will be in the bracket. So when we substitute this, we are only going to take the value of G, only the coefficient of x. And therefore here we have 4x. That means G, we substitute it with 4. And then we open our bracket, and then you write all the function of f. And the function of f is given as 2x plus what? Plus 1. Then you close. And then now when you open the bracket, we say 4 times 2, we get 8. And then 8 times x, we get 8x. And then since it is 1 is inside the bracket, we also going to multiply 4 times 1, which will give us plus 4. Plus 4. So this is our answer. Then you come and say, therefore, GFG of x will now be 8x plus 4 as our answer. So that will be our answer for part B and part A. So we are now left with the part C. So part C, here they have given us now the value of x. So normally equations on composite functions, they will ask you to find in unknown and then in known. So part C, the value of x is given. Now what will be the outcome of that relation? Since the x is known, then now we go back to our part C. So our part C, we simply say C is given as G F and x is given as 0. So since x is known, then we simply go back in this part here, part A. What is the part A saying? The part A is giving us this. We substitute that. We simply say we shall have 2 into x into 4x plus, close the bracket, plus 1. And since we know that the x is 0, so if x is 0, then where there is x, we are also going to substitute it by 0. So we shall have 4 times 0, close the bracket, plus 1. And then now when we simplify inside the bracket, we get 2 into 0 plus 1. So 2 times 0, it will give us 0. So our answer will give us, will remain as 1. So you say GF of 0 equals to 1 as your answer for this case. And then lastly, part C, part D. So part D, So part D is x is given as 2. X is given as 2. So x is given as 2. Then now we say D equals to is given as FG. FG, which is 2. So this one automatically it will be G out and X out. So you shall have 4 into 2x plus what? Plus 1. Close the bracket. So if x is 2, if x is 2, what will be this outcome? So we shall have 4 into 2 times 2 plus 1. And then now you will maintain your 4 out, and then you have 2 times this, we get 4, plus 1, we get 5. So then you open your bracket. So the answer, final answer will be FG of 2 will give us 20. Will give us 20. So learners, with that, I believe you have picked something from the composite function. And I say let our lesson has come to what? To an end for now. We shall pick up from where we have stopped under composite function. So with this, I wish you the best, and I hope we shall meet again. Goodbye.